Hello everyone, it's my honor to present the work here today and I hope you like it. My name is Badio Luiz de Castro Silva. I will present the work titled Spatial-Temporal Segmentation of Satellite Image Time Series using Self-Organized Map. With the advancements of space technologies, terabytes of satellite image data are generated daily. One estimate from a data center in Germany is that at least 100 petabytes of Sentinel-2 data will be stored by 2030. And also due to the changes in the data distribution policies, technology development in remote sense has been rapid, with the new approaches to using the big data. One of the most important activities related to use of the remote sensing images is the generation of the land use and the land cover maps, which is very important for public policy and decision making. Various techniques such as data processing, classification, and segmentation can be used to create this map. With the big data, new approaches can be implemented. Recently, several studies have shown the use of spatial temporal data is promising and significantly increases the accuracy of the models compared to approaches that do not consider time. For this work, we will use the segmentation technique. What is a segmentation? Segmentation consists of dividing an image in homogeneous regions based on some criterion, be it a color, texture, or intensity. It is an example, we have a 6x6 image that has been divided into three homogeneous regions using the criterion of the color. Now I will introduce the concept of spatial-temporal segmentation. In the same way of the segmentations, you want to divide an image into homogeneous regions, with the difference that criterion of the homogeneity is the time series. In this example, we have a 6x6 image in 4 different times, and these pixels highlighted by the red, for example, is represented by a time series of the 1112, and this lower pixel represented by the time series 2222. Note that these 2 pixels will be in different regions. From this, we can see the image has been divided and the 4 different regions whose criterion is the time series. Thus, the technique that will be presented in this work is space first, time later, or time first, space later. Space first consists of using images separately and then compared in the time. The time first uses the time series separately and then results are merged. So for this work, we use the concept of the time first and space later. The proposed methodology consists in extract the time series from the data cube, process the series to remove the influence of the clouds, and perform clustering using the time series as the input of the self-organized map, which has input some weight vectors, called the codebook vectors, that serve as inputs to the next clustering, performed with the hierarchical clustering, that defines the number of the final clusters. From the definition of the final number of the clusters, the unsupervised classification map is created with the goes through a process of the spatial smooth and generates the final segmentation. The study area of the work is located in the southeast of the state of the Mato Grosso and is a very heterogeneous region consisting of vegetations, water bodies, urbanized areas, agricultural areas, and among others. The data cube for this work is a Sentinel-2 with the 26 days temporal compositions using the best pixel approach. The temporal resolution is from August 2019 and August 2020, which correspond to 23 images in time, and the spatial resolution is 1954 by 2188 images, and the spectral resolution is composed by the NDVI, which is composition of the red and the infrared bands, and these are the set and used. Here is the GIF of RGB images for understanding a little about the temporal dynamics of the region. Here we have an example of the two time series, one treated and one untreated, where is a cloud mask makes the cloud identifications, and then a linear interpolation is done, as seen in this region. The input data is just over 4 million time series. The self-organized into a grid of the 144 neurons. This results in 144 codebook vectors that serve as inputs to the hierarchical clustering that determines the final number of clusters for the final map generation. I have selected some neurons to better understand the time series they represent, which characterizes the dimensionality reduction. And all these time series are represented with a codebook vector. The dendrogram shows the whole 144 patterns integrated in the 4 regions defined with the dashed line. On this slide, you can see the distribution of the clusters in the neuron grid, and also the time series represent each cluster calculated using the average of each codebook vectors integrated into the same cluster. Here is seen how the self-organized map grid is with the codebook vectors and which cluster it was represented by color. After creating the unsupervised classification map, spatial smooth was applied, which takes a 7x7 neighborhood of the pixel and it calculates the mode, which is the example is the 2. The central pixel is replaced the modes of the neighborhoods and executed for all pixels of the image. For this work, the map of the Terra class project developed in Brazil is used as a reference map. In a qualitative evaluation of SUMATI using the supervised classification maps with 4 clusters and the unsupervised classification maps with the 12 clusters. Here we see the difference between the maps with smoothing and without smoothing with the 4 clusters. I would like to draw attention to some trails in these regions. They were lost due to smoothing, and some regions that become more homogeneous, such as river edges. We can see as a good distinction between the vegetation regions in green and the rivers in blue and the urban areas in orange and the other regions. Now we see the map with 12 clusters without smoothing and with smoothing, which have more details related to the 4 clusters. I want to draw attention to the areas of vegetation where it is divided between denser vegetations and less dense. Agricultural regions also received a good distinctions in relation to the others. I want to remind you that each color on the map is represented by the time series that can be analyzed by experts for interpretation of your spatiotemporal pattern. There is a region where there was urban expansion or forest fire or has a characteristic temporal pattern can be represented by a cluster or layer a polygon. If you look more closely at these regions, you can see the map with the 4 clusters. And draw attention to the map with the 12 clusters and the upper right in pink, where Terra class classified the temporary crop is well distinguished from the others because it has the characteristic patterns of the 2-cycle crop. After the vectorization of the unsupervised classification map, we will have the results of the spatiotemporal segmentation. The qualitative evaluations was also performed, where some polygons were selected for comparison with the references, and these were results of the metrics. Conclusions. Characteristics temporal profiles such as agriculture, deforestation, and forest fires can be represented by a segment. Great potential for different applications, use of other spectral bands to explore a specific target, is produce a good delineations between vegetations, river, and urban areas. Here is some references of the paper. And thank you for your time.